Okay, you guys. So today, now that you have a little bit of experience with systems, with graphing, we're going to move to 3.2, which is solving the systems algebraically and using them in a real life scenario, like on word problems. Okay, so I'm going to show you on the model and discuss that we can do something both ways and still get the same answer, and that sometimes it might be a little bit easier based on the types of problems you're given in your system. So we're going to start with graphing, and the first one that we're given, we have two different equations here, y equals -3, and then 3x plus 4y equals 12. Now, this is a Hoy because it is only a y equals, so we're going to have y equals -3. I'm going to have my horizontal line down here, so I'm just going to come across at -3 and put my points, okay? Then for my second one, it's not in slope-intercept form, so I have to rewrite it. I'm going to subtract -3, or 3, sorry, and I have 4y equals -3x plus 12. Second step is to divide by y. So I have y equals -3/4 x plus 3. I'm going to graph that, go to 3 on my y-intercept, and my slope is 1, 2, 3 down, 4 to the right. 1, 2, 3 down, 4 to the right. Okay? And you can tell where these two intersect. Now, we know from our experience with solving and graphing in the last one that we don't always have a graph available to us. So we need to know a lot of different methods to do things for when there's not a graph always there for us, okay? And you can see this one is at 8 for the x and then down 3 for the y. So my solution is 8, -3. So when there's not something always available to us for a graph or a picture, we have to know how to do things algebraically. And that just means substituting and solving. So when we're using substitution, it's exactly like what the name says. We're literally substituting a value in for one of the variables. Now, these two again are y equals -3 and 3x plus 4y equals 12. So in this, I have y equals, I'm going to take this number, -3, and plug it in here for y. Okay, substitute it in. So here we go. 3x plus 4, y comes out, and -3 goes in, equals 12. So the only thing I did was replace my y with the value that it tells me that it equals. Now I'm going to solve like normal. So I have 3x, 4 times -3 is -12, equals 12. Now I have a two-step, so I'm going to add 12 to both sides. 3x equals 24, divide by 3, and x equals 8. So now if you notice, x equals 8 here, x equals 8 over here, y equals -3, and y equals -3 here. Okay, so the answer is exactly the same. There's just a different method of doing it. And this one doesn't require you to have a graph. All right. So substitution, again, is going to be taking the value for one of the variables and plugging it in or substituting it into the other equation to find the answers. Okay, so here we go. I have y equals 6x plus 7, and then 3x minus 8y equals 4. Now you're going to know which one to pick because one of them is going to be equal to a single variable. So instead of just -3, this whole thing is what y is equal to. So I'm going to take this whole thing and plug it right in here for y in the other equation. Everything else stays exactly the same. So 3x minus 8, I'm going to take out y, and in its place, I'm going to put what it told me y was equal to, 6x plus 7. Everything else stays exactly the same. Now I can solve for x because it's my only variable. So I'm going to distribute -8 here. 3x minus 48x minus 56 equals 4. Combine like terms. 3x minus 48 is -45x. minus 56 equals 4. I'm going to add 56 to both sides. Negative 45x equals 60. And when I divide by negative 45 on both sides, I get that x equals negative 1 1/3. Okay, so there's my x value. Now I need the y value, because remember your answer is going to be an ordered pair that has a value for both x and y. Okay, so the easiest way to do that is to take it and plug it back in the other equation. So if this is the value for x, this is already set to y. I'm going to plug it in right here for x. So I have y equals 6. X comes out, and the value for x goes in, plus 7. Okay. When I multiply those in my calculator, I get y equals negative 1. So my answer, official answer for my ordered pair, is going to be negative 1 1/3, negative 1. Okay, so if I were to graph those on an actual graph, that's where the two lines would intersect. Okay, all right, let's try another one. So this one is a little bit different in the fact that it has two of them that are equal to y. So in this case, it doesn't matter which one we pick. So I usually always just start with the top one. If this is what my y value is equal to, it goes in for y in the other equation, and everything else stays exactly the same. So the left side, instead of putting y, I'm going to put in what it told me. So negative x plus 2. I don't need parentheses this time because it's nothing else on that side, equals, and everything else over here drops. Okay, now we can solve variables on both sides. So I'm going to add 6x to both sides. This gives me 5x plus 2 equals negative 3. Down to a 2-step, subtract 2. 5x equals negative 5. Divide by 5, and x equals negative 1. So there's my x. Now again, I'm going to take this and plug it back in for the x up here in this equation. It doesn't matter which one you use. You could plug it in the bottom one. No worries on that either. Again, just habit of mind to be able to pick the top one if they're both the same. So y equals, I have a negative sign, and then x comes out, and the value for x goes in. So negative 1 plus 2. Back-to-back negatives here make this positive 1 plus 2. So y equals 3. So my final answer, as an ordered pair, would be negative 1, 3. And again, if you wanted to check yourself, you just plug those values back in here for what it has. So this would be 3 equals negative 1 plus 2. We just checked that one. This one would be 3 equals negative 6 times negative 1 minus 3. So this would be 6 minus 3, which equals 3. And that's how you make sure you're correct. Okay, let's keep going. The next one we have, again, top is the y equals. It's all by itself. Okay, so I'm going to take whatever it says y is equal to and plug it in for that variable in the other equation. Everything else stays exactly the same. So I have 6x minus 2. Y comes out, and the value of y goes in. 3x plus 1 equals negative 2. Now we solve. I'm going to distribute negative 2. 6x minus 6x minus 2 equals negative 2. If you notice, these are going to come together and cancel out. So now I have negative 2 equals negative 2. And we know that when we lose variables, we have two choices for answers. If these are the same, then we have infinite solutions. The same that we learned in our first unit on solving equations. Okay, let's try a different one now. How about with x? So the first one has both variables. The second one has x equals. So here's what we're going to circle to put in the top one. Okay. Just substituting for x this time first instead of y. So again, everything else about the top stays the same. So I'm going to start with a negative, parenthesis, and my value for x goes in its place. 5y minus 4 plus 5y equals negative 4. Distribute this negative sign, so negative 5y plus 4 plus 5y equals negative 4. Again, if you combine like terms, they're going to cancel. So now I have 4 on the left and negative 4 on the right. Those are not the same value, and we have no variable, so our answer is no solution. Okay, so if you remember back to our graphing the other day, if these are infinite solutions, these two equations are exactly the same. So if you were to rewrite this guy, you would get the exact same equation as you do up there. Because these are no solution, these would be parallel lines because they will never intersect. Okay, so think back every time about what it is and why you got that answer. Okay, here are your triads. So pause the video and then come back and check each one as you're doing it. Okay, so top one has x equals. We're going to circle it. I'm going to plug it in here for x. So I have y plus 6 plus y equals 10. I took out the x and put the value in there. You can put it in parentheses, but it really doesn't mean anything. So combine like terms gives me 2y plus 6 equals 10. Subtract 6. 2y equals 4. Divide by 2, and y equals 2. Now let's take that and plug it back in at the top. So y is 2, which means it's going to go right in here, this top equation. X equals 2 plus 6, so x equals 8. And our final solution would be 8, 2. Okay, let's go to the next one. So now the bottom one is a y equals, which means it's going to go straight in here for y in the top equation. Everything else stays, so x plus y comes out, and negative x plus 5 goes in, equals negative 4. Combine like terms, so x minus x, these are gone, and I have 5 equals negative 4, which it does not, so this is no solution. And again, I hope you're thinking in your head, if there's no solution, that means these would be parallel lines. Okay. All right, next one. Top one is our variable. So I'm going to plug it in for y. Everything stays the same. 2x plus 3. Y comes out, and what we circled goes in its spot. Everything else stays. Let's distribute 3. So I have 2x plus 6x minus 3 equals negative 7. These go together, so 8x minus 3 equals negative 7. Add 3. 8x equals negative 4. Divide by 8, and x equals negative 1/2. Okay, so again, let's plug that in. X is going to go right in here for our top one. So y equals 2x, 2. X comes out, and 1/2 goes in, minus 1. And we have that negative 1/2. Half of this would be negative 1 minus 1. So y equals negative 2. And your final answer then would be negative 1/2, negative 2. Okay, hopefully you're doing okay. Let's go to the last one here. So on the top, we have our y equals. So I'm going to circle that. It's going to go in for y in the bottom. So 2x plus y comes out, and I've got negative 2x plus 5 equals 5. Combine like terms. Well, those are going to be gone because it's 2 minus 2. So I have 5 equals 5 left over. Those are the same. So these would be infinite solutions because everything would work. And again, on a graph, I hope you're thinking that these would be the exact same line. Okay. All right, let's flip it over. And we're going to do the back with our word problem here. Okay. So Nate starts a lawn mowing business. In his business, he has expenses and revenue. So expenses are things that cost you money. Revenue is what you earn. Nate's expenses are the cost of the lawnmower and gas that he has to put in it. His revenue, or his money he's making, is $25 per lawn. At what point will Nate's revenue, or his income, exceed or pass his expenses? So when will he start making money after he's covered the cost of his lawnmower and gas? Okay, so we need to make two equations. Remember, this is all about systems. So you're making two separate equations each time. All right. And we're going to be solving for x and y, and then we will know after we solve which one we need, x or y. Okay. So when we think about it, it says $25 per lawn and gasoline is $2 per lawn. So when we have that, we know that x is going to be our slope, or our thing that's happening over and over again. So x is going to be our number of lawns, right? And then y would be the total amount of money he has or has earned after X number of lawns, because that's going to be your y equals mx plus b, right? So our first one is going to be about his expenses. So his expenses are $200 for the lawnmower, which only happens once, we hope, right? And $2 per lawn. So y equals 2x plus 200. 2 for each lawn and $200 one time for the lawnmower. Then an equation about his revenue. And for the revenue, his total money will come from $25 per lawn that he mows. Okay, so now we're going to use our systems to solve. So again, it doesn't matter here which one you pick because they both say y equals. I'm going to take the bottom one and just plug it in here for the top one. So we're going to have 25x equals 2x plus 200. Okay, this is going to be subtract 2x to move it together. So I have 23x equals 200. Divide by 23, and x equals 8.69 about, I should put an about sign, lawns. Okay, so he has to mow 8.69 lawns for these to be the same, because this is equals, right? We want to know when it will exceed his expenses. So he has to mow 8.6 would mean he'd have to mow 9. So he would have to mow more than 9 lawns in order for it to be more money than cost. Okay. All right, let's try another one. Pause it, try one on your own, see if you can make your two equations, and then let's solve for both of them. Okay. Funtime Amusement Park charges $12.50 for admission and then 75 cents per ride. River's Edge Park charges $18.50 for admission and then 50 cents per ride. For what number of rides is the cost the same at both parks? Okay, so again, you're trying to make your two equations, right? X is going to equal something that happens over and over again. So that would be your rides. So the number of rides would be X, and Y would be your total amount that you're spending. Okay? So let's write an equation for fun time, write an equation for river's edge, and then we'll put them together. So for fun time, Y equals, our slope would be 75 cents per ride. That's the thing that's happening over and over again, plus $12.50 for admission. Then for river's edge, your slope would be 50 cents per ride, plus $18.50 for admission. Okay, so let's solve these by using our substitution. Again, it doesn't matter which one you pick because they're both y equals, so I'm just going to pick the top one and plug it in for the bottom. So I have 0.75x plus 1250 equals 0.5x plus 1850. Okay, I'm going to start by subtracting my x's. And I have 0.25x plus 1250 equals 1850. Subtract 1250. And I get 0.25x equals $6.50. Oh, sorry, $6. Let me erase that. Okay. Divide by 0.25. And x equals 24. And remember, x stood for number of rides. So at 24 rides, these two will be exactly the same. Okay? Now, the bottom three are for you to try on your own for substitution. We'll go over them tomorrow in class. Okay? Work hard. Remember, whatever one is equal to it, you're going to plug it into the other one, and then you're going to use everything else exactly the same. Okay?